Hi everyone, welcome back to the course manufacturing process. Today we are going to discuss about shape rolling. What is shape rolling? Producing a shape, a particular shape like I, L or U using a rolling process that is called shape rolling process. Work is deformed into a particular cross section, usually rectangular. Products include I-beams, L-beams, U-channels, etc. They are basically used for producing rails for railroad tracks, and round and square bars and rods. Rolling mills. What are the different types of rolling mills? Rolling mills are the equipments which are used for producing the parts using rolling operation. They are quite expensive and massive. Different types of rolling mills are 2-high rolling mill, 3-high rolling mill, 4-high mill, cluster mill, and tandem rolling mill. Let us start with 2-high rolling mill. The workpiece is fed between two rolls. They rotate in opposite direction. The material will get squeezed or compressed, and the thickness of the material reduces. So the material is shaped into the required specification or shape by squeezing or compressing between the rolls. So you can see here a small 2-high rolling mill. Here the material is fed between the two rolls. The material will get compressed or squeezed, and it will come out with a specific shape and dimension. Now we have 3-high rolling mill. In 3-high rolling mill, we will have two passes. In first pass, material will be fed between the two rolls. The rolls are rotating in opposite direction. So initial compression takes place. There will be a specific draft here. Some amount of reduction in thickness will take place. And in the second pass, material will be taken out and fed between roll 2 and 3. So this is called the second pass. So by doing this, a significant amount of thickness can be reduced. A significant reduction is possible using 3-high rolling mill. Now we have 4-high rolling mill. In 4-high rolling mill, there are two work rolls and two backup rolls. The work rolls are supported by the backup rolls, and material is fed between the work rolls. Material will get squeezed, compressed, and deformation takes place for the specific material or part. So in order to avoid deflection, we use back rolls. They support the work rolls, normally used for reducing thickness in sheets, foils, etc. Now you can see cluster mill. Multiple backing rolls allow even smaller roll diameters. We use smaller roll diameters, and here multiple backing rolls are used to support the work rolls. As you could see here, very small work rolls and supported by several number of backup rolls to avoid any reflection, and tin foils can be produced using such kind of mills. This is called the cluster mill. Now tandem mills, a series of rolling in sequence. As you could see here, the first one, a reduction in thickness takes place, then it is sent, the material will be passed through the second set of rolls, then to the third set of, so a continuous, a sequence of rolls or rolling mills are there. Continuously the thickness will be reduced, and when we get at the final stage, there will be a significant reduction in thickness, as I explained before. Now, thread rolling is basically used to produce thread on the cylindrical parts by rolling them between two dies. It is an important commercial process for mass production of bolts and screws. Advantages of thread rolling in comparison with thread cutting is basically they are used for high mass production, better material utilization, stronger threads, and better fatigue resistance due to work hardening. Now, thread rolling, as you could see here, this is the starting stage. There are two dies, fixed die and moving die. Fixed die will be fixed at one point, and the material or cylindrical material or workpiece is kept between the two dies, fixed die and moving die. And as the moving die moves, the impression on the die, that is thread, will be formed on the surface of the material. This is basically used for producing bolts and screws. This is the end of the cycle, and this is the starting point. Now, ring rolling is production of rings. Smaller diameter is rolled into thin-walled with having a larger diameter. As thick-walled ring is compressed, deformed metal elongates, causing diameter of ring to be enlarged. Hot working process for large rings and cold working process basically used for smaller ring. Where we use it, we are using them to produce ball and roller bearing racers, steel tires for railroad wheels, and rings for pipes, pressure vessels, and rotating machinery. These are the applications of ring rolling. As you could see here, there are rolls in here, main roll supported by idler roll, and then as they rotate in opposite direction, the diameter of the ring will increase and its thickness reduces. This is called a ring rolling process. Several steps of ring rolling process can be seen here. So finally, we start from the workpiece, after compression, and then rolling starts, ring rolling starts, work roll and idler roll, and then finally what we get a ring having a specific thickness. So one of the solved example is given here. A plate of width 250 mm and thickness 25 mm is to be reduced into a single pass to high rolling mill to a thickness 20. So 25 millimeter thickness need to be reduced to 20. So initial thickness is 25, final thickness is 20. Width is 250 millimeter. Roll radius is 500 millimeter. Its speed is 30 meter per minute. The work material has a strength coefficient K is 240 megapascal and strain hardening N is 0.2. Determine roll force, roll torque, and power required. Here, what are the things we have? We have width of the material given. 25 millimeter thickness need to be reduced to 20 millimeter by a 2 high rolling mill. The radius of the rolling mill is 500 mm and speed is 30 or velocity of the roll is 30 meter per minute. Work material has K, strength coefficient 240, and N, strain hardening coefficient 0.2. We need to find what is the roll force, what is the roll torque, and power required to accomplish this operation. Let us find draft first. Draft means how much thickness reduction is possible using 2 high rolling mill. That is initial thickness 25 minus final thickness 20 will give you the draft. Then how much is the contact length between the roll and the workpiece? That is equal to square root of you can see the values are given here. 500 is the length and 5 is as you could see here, 500 is the length and 5 is the draft. Square root of the radius times the draft will give you the contact length. Then we can calculate true strain using this equation. Log final thickness divided by initial thickness, we get a true strain. Then flow stress is equal to K epsilon raised to N divided by 1 plus N. Then rolling force F is equal to, we can calculate flow stress times W times L. Torque also we can calculate using the equation 0.5 F times L. L is the contact length we already calculated, and power we can calculate 2 pi N FL. Using this equation we can get power also. So this example we are going to discuss in the tutorial class as well. Please go through it. Thank you very much for listening.